When you are at school, you can use balls or any spherical objects like this globe that I have here to model the Earth's rotation. I want you now to look closely at this model. Here I have the globe, and here I have this object to represent the sun. As you can see, Earth here, it rotates around its own axis. As you can see here. So, as I turn here the globe, this part of the Earth is directed to sunlight, so it experiences day. But this part of the globe, it's not exposed to sunlight, so it experiences night time. If we turn this globe around, now this part here experiences day, and the other part that is not exposed to sunlight represents and experiences nighttime. Do we need to rotate the sun? What do you think? Of course not. The sun here is the center, so it forces the other planets to revolve around it. The rotation of the Earth causes day where light is facing the Earth, and it will be dark on the other side, as I showed you now. This is day and night cycle. But what is a cycle? Do you remember the cycle of the energy flow? It always starts with a producer and ends at the decomposers. To start all over again with the producer, and it goes on and on. This is a repetitive series of events, and we call this pattern the rotation of the Earth on its axis, which causes day and night. While the revolution of the Earth around the sun causes another pattern, it also causes the yearly cycle of seasons. Now, can you think of other examples of cycles? We have already mentioned two of them, day and night, and the 4 seasons of the year. There is also the water cycle. Now, let's go back to the question of what would happen if the Earth stops rotating on its axis. يا ترى إيه اللي هيحصل لو الأرض بطلت تدور حول محورها؟ I want you to pay attention here. Now, the globe is rotating. Earth is rotating around its own axis. Now, pay attention if it stopped. So when it stops, this means that this part and these countries are only directed to the sunlight. So they are going to experience day the whole time. So this side will remain day all the time, and this side will always be night. So there will be no cycle at all. The cycle of day and night gives the two parts of the Earth equal access to sunlight. And this is important for the survival on Earth. That's why the last activity in our lesson is Analyze Like a Scientist. This activity is titled Sunrise. Our objective is to analyze data to identify patterns about how Earth's rotation causes patterns of night and day. And I will have a very quick demonstration on this model here. I want you to look closely here at the globe. As you can see, the globe is tilted on its own axis, and it's not straight. And as you can easily observe as well, that the Earth is slightly tilted on its axis. So the part facing the sun is day, while the part away from the sun is night. Because of this tilt, the sun will set and rise at different times, even in the same area. Now let's say that it is noon right now, where you live. So where on Earth do you think it is midnight? We're going to hear these answers from our colleagues.
If it's noon where I live, it will be midnight on the other side of the earth.
Thank you, our colleagues. That's right. if the sun is exactly above at noon, surely the exact opposite side of the earth will be midnight. Now, let's start our activity on the textbook. And we're going to look closely at a map. Let's go check it out. Let's look closely at this map here. Here is east, where the sun rises, and here is west, where the sun sets by the end of the day. Get your pen and read the text to identify the information that we need. Earth's path around the sun is not perfectly circular. It is elliptical, and Earth rotates clockwise on its axis. Earth's rotation, as we said, it is elliptical like an elongated circle or oval. And as we explained on the clay ball, Earth is also slightly tilted on its axis. So the angle of the tilt changes throughout the year. Okay, so what is the result of this tilted rotation? Let's read the last part of the text to find out. So, the combination of Earth's elliptical orbit and the tilt of Earth on its axis results in the sun appearing to travel in different paths across the sky at slightly different speeds each day. So, the shape of the Earth is oval and it is tilted on its axis. So, when the Earth revolves around the sun, the places on the globe take different amounts of sunlight, because in one place it will be directly facing the sunlight, and in another place we'll get less sunlight. And some other places as well will not be exposed to sunlight at all. بسبب ميل الأرض على المحور بتاعها بيخلي مدة الليل والنهار بتختلف على سطح الأرض. So that's why even in places facing the sun, the sunrise timing will be different. Imagine if the Earth rotates in a circular orbit, not an elliptical one, and it is not tilted on its axis. So what would happen? Let's watch how the model will help our colleague to find out this answer.
If the sun is vertical in this way on the earth, so it would rise and set at the same time.
Thank you, our colleague. There is always a time difference between sunrise and sunset in different cities in Egypt and in a single city. Let's find out more about that through the map. So, as you can see here at the map, we have those cities, and the cities are spread out all the way to Egypt. We have here this side, as we mentioned before, is east, and these cities are in the west, very far from where the sun actually rises. So let's start reading the questions based on this map. So, the first question that we have: which of these cities in Egypt is located the furthest to the east? Right, it's Marsa Alam. So which of these cities here in Egypt is located furthest to the west? Let's take a look at the map. Oh yes, it is Siwa. My question is, which of these cities we will see here will see the sunrise first, and why? Because the sun rises from the east, so the sun rises in Marsa Alam first, because it is the most eastern city in Egypt.
تقدر تتابع كل دروسك على تطبيق مدرستنا بلس. مدرستنا، المستقبل يبدأ الآن.